Okay. Hello, everyone, and we'll continue to our next session. So, you are welcome to the virtual OWASP Bistro 2020. You are on track A, and our next session going to be the DevSec Oops, how Agile Security increases attack surface. And our presenter today is Denis Makrushin. He's the head of advanced security research at Huawei Moscow. So as you know, Agile paradigm changed the landscape of product delivery by adding new processes like CI/CD. We have pipeline, we have managed tools, we have security automation tools like static analysis, dynamic analysis, etc. And we also have new roles like security engineers now part of the DevOps team. And all of these increases our attack surfaces. So I just wanted to say thanks our sponsors, Checkmarks and the Amdocs. And Denis, you're welcome, and go ahead.
Hello, dear colleagues. Thank you, OWASP organizers, that you allow us to inject our researchers, our insights in a daily routine. And before I start my presentation, I just want to ask you colleagues who are listening to me right now to raise your hand only if you are related to DevOps processes. If you are not related to security directly, but if you are your daily routine is development or operations. And you can raise your hand in chat, or you can mark something in the chat if you are DevOps. I just want to understand the statistic, what part of audience is related to DevOps process. And if you raise your hand in offline, okay, just drop your hand. And if you are security enthusiast, or if you are a security specialist who focused on application security aspects or development security operations, DevSecOps, or if you are infrastructure security expert, please raise your hand also. Yeah, and if you raised your hand in this case, I think the statistic in this, usually in this audience, in this events, like OWASP, it's something like that. So sometimes when you ask someone, please raise your hand if you are playing for the blue team, if you are defenders, if you are trying to secure your operations, you will see that a lot of people in the chat or in the offline audience most of them raise their hands that they are players for the blue team. And sometimes if you ask who is the red teamers, guys, please raise your hand, you see that couple of red teamers. And sometimes you know that we can conclude the statistic, it's something like that. All of us who involved in the pipeline, in development and security operations, we are blue teamers. But the balance of success between red teamers and the blue teamers, it's quite opposite statistic, because you know that you need to be successful only once if you are attacker, if you are red teamer, but you need to be successful 24 hours, 7 days per week if you are blue teamer, if you are trying to protect your system. And this is a disbalance. This is the difference between blue team challenge and the red team challenge, between attackers and defenders. But this presentation, I want to show you the different point of view, how we are, like red teamers, like DevSec operations, like application security experts, how we are change the attack surface, how we affect the security state of what we're trying to secure. My name is Denis Makrushin, and I head application of advanced security research at Huawei, but formerly I was the head of application security in a big company. So I think I'm a little bit understand the pain of security researcher and people who involved in DevSecOps, like defenders. And I'm going to share my experience with you. But before I do that, this is a coming out from my side. I just want to say that funny story that 2 years or 3 years ago, I was a security researcher, and healthcare industry was the object for me, the object of my research. And I'm trying to search different vulnerabilities, misconfiguration in healthcare organizations. And when I'm trying to find some vulnerabilities, I'm trying to submit these vulnerabilities in different medical system, medical record system. But after 2 years, um, I realized that the healthcare organization, the object of my research, it's not a developer. It's not a developer of the vulnerable system. It's not a developer of vulnerable products, or not a developer even. And their users, the healthcare organization there who was affected by different kind of vulnerabilities, the products that was affected by different kind of vulnerabilities. It's just a users of the product. And developers, it's little bit different organizations. And my target was not it was wrong target. And according to existing statistic, for example, this is the BSIM statistic according who is the main developer of healthcare product, you can see that independent software vendor who focuses not only on healthcare, they also provide and produce some kind of products for healthcare organizations. So they should be the object of my researches. And I was realized that it was a wrong target. And I decided to focus on development process, on the developer side, not just on the users, but on the developers who can be the start point for the attack. So, and I decided to look at the security in developing and independent software vendors. And you know that if you're trying to look at the software procedures right now, in this year, you will see the terms agile. And this agile everywhere, agile development, agile methodologies, a lot of agile. I'm not sure that I'm correct in with this term, but maybe you can correct me. But Agile has the 3 main principles, and Agile Security following for the same principles. First principle is that do not reinvent. So do not reinvent the bicycle, just use existing solutions, use existing methodologies, approbations, and researchers to improve it. The second principle, do it incrementally. So do not reinvent your core product, your core part. Just increasingly and accurately improve your core, and try to check your improvements, your updates, and be careful to not affect the core part of your product. And of course, automation. Automation is everywhere. You need to write your tools. You need to write new deployment methods. Do not use human power, use the machine. So this is the 3 principles also following with the security, with Agile Security. And the Agile Security brings new people, new process, new tools in our development lifecycle. You know that 10 years ago, it was only developer and operation expert or administrators. Right now, we can see the people who named themselves like DevSecOps experts. We familiar with the new kind of processes, continuous integration and delivery, etc., and tools, a lot of tools. And if you're trying to secure any organization that is a developer of IT product right now, you will see that if you were trying to start from the scratch, trying to start to implement new methodologies like OpenSAM, you will see that the process from the researcher and from the application security expert point of view is a little bit not so clear, because everyone in the company share, every team, development team or testing team or operations team, they share responsibilities. They are always merge different kind of components between the team. So there's the chaos, yes, for the first researcher's perspective and the first point of view. But the process, it's okay. You can understand the process. You can bring some developer and sit with him and say, you will fix my bug. Yes, so you can solve the problem somehow. But if we were talking about automation, you will see that there are a lot of tools. That is a base for another tools. These tools generate new frameworks. Frameworks generate new solutions. Software as a service generate new software as a service. So this is the chaos too. And this soft, mostly not only people but soft, it's increased dramatically the attack surface. Yes. And before we jump to the attack surface term, let's describe what is that from the formal perspective. Yes, from the academical point of view. So, and let's consider what is attack surface based on this simple scheme. It's just, let's imagine the network where you can have access to 3 or 4 elements. Host 0 that divided between host 1 and host 2 by firewall. So that's quite simple network. So what is attack surface? Attack surface is the number of steps that attacker should perform to achieve the crown of jewels for on the host 0, on the host 1. And in case if firewall is switched off, you can achieve your crown of jewels using one number of steps. It's a picture below. It's picture above. But if you switch on your firewall, the number of steps will be increased because you need to compromise the firewall, and sometimes you need to bypass it. Sometimes you need to find vulnerabilities in the firewall, but you still need to perform another number of steps. So attack surface from the formal determination, from the formal term, is the number of steps that attacker should to perform. It's a graph of the attack, and this is a characteristic of this graph. So how we are, as a security researchers and application security engineers, how we are affect this graph, how we are affect this attack surface. There's a picture and an answer. If you see this process of typical product life cycle, you can divide it on the key steps when the product appears in the code, when the product is in testing environment, when the product is deployed in operations environment. If you bring security engineer in this process, you will see that this engineer changed something on code stage. Yes, he changed this, he implemented the security testing, the code testing, the SAST, DAST, etc. SAST only, not DAST. Next step, he will implement DAST. He will implement another tools that verify your product before it will be deployed. In deployment stage, this engineer will implement another policy, another strategies for bug bounty, for example. Yes, he will try to involve more people to assess your product. So, but the key point is this engineer will affect your chain, will affect your number of steps. And if you are trying to scan the attack graph of trying to scan the typical network, enterprise network, yes, with a lot of hosts internally, not externally, but internally, you will see that a lot of exposure assets available for internal attacker. Sometimes it's available, the same graph you can see with the external networks, yes, a lot of assets exposed to the internet. And this is okay, it's okay with a big organization because administrators left, someone changed their team, he forgot about the asset. The assets can be forgotten by IT security, etc., etc. A lot of reasons why it could be forgotten, but assets still exposure. And let's divide this number of assets on the three types, divided by color. First type of assets will be allocated for development stage, second for quality assurance stage, and third is operations related stage. And let's describe each interesting examples from the experience, what kind of assets exposed by security engineers. So, but before we started, the question for you, just to think, what do you prefer more? Do you prefer commercial security solutions or do you prefer open source? And before you provide an answer by yourself, yes, for yourself, I just provide my personal answer that I prefer commercial solutions mostly because prefer commercial in my daily routine, in my job, because I'm sharing responsibility for the product with the vendor, but sometimes community can help you. Yes, if someone found the bug in the open source instrument, and who you should ask about how to get the fix for the bug. That's why my personal preference is the commercial solutions in commercial organizations. And I think this way, most of security engineers thinks the same. If you try to scan for exposed assets related to security stuff, you will see that, for example, Sonar Cube, the solution that usually used for code quality or security assessment of your code base. And if you're trying to assess the exposure to Sonar Cube worldwide using the showdown, you see the following statistic that some Sonar Cubes exposed online. In this Sonar Cube, sometimes available without any registration. You just can have the login. For example, you don't need to log in inside the Sonar Cube. You just can check the assessment. Just open the page and you will see intellectual property. You will see some reports. You will see some code maybe. Or another example, you don't need to log in there. You don't need to root default credentials. You just can register there because registration is open for everyone. And someone can register there and can scan their own code, yes, or he can steal or existed intellectual property there. So it's exposed, yes, not so good statistic, but sometimes these forgotten Sonar cubes or these exposed Sonar cubes can be an entry point for attacker. And if you try to use the GitHub scraping to assess the potential interesting and potential secrets related to Sonar Cube installations, you need to just input some keywords, and these keywords will show you all automation scripts. Remember the third principle of Agile, automation. So most of the developers, they use this principle, but they upload their work assets or work scripts into the GitHub. That's why sometimes you can, if you are a pen tester, you can find something interesting using the just GitHub scraping. Another example, you can extract some sensitive keywords from the documentation of Sonar Cube to extract interesting keywords for scraping, for Googling, and for dorks, for your dorks. In this case, Sonar Cube supports command line integration for automation. And sometimes you can see that some scripts exposed without any, with the secrets. And these scripts can be reused to get access to the Sonar Cube. Yes, you can say that Sonar Cube mostly it's not about security. Yes, it's mostly about the code quality. It's not related to my workflow. But any solutions that could be delivered software as a service, they could be exposed. And for example, you can check your favorite SAST, static application security testing tool, and you can try to search exposed SAST assets worldwide. And you can mention any kind of vendors, and you will see that sometimes, if wrongly implemented by security engineers, the solution can be an entry point to the infrastructure. And engineers should be aware how to implement security solutions. It should be implemented internally, not externally. And sometimes, because some of those SASTs, they support also automation scripts, it's common integration, something like could automate the workflow with security engineers. You can also check the automation scripts on the GitHub that exposed by, maybe it's exposed by security engineers, maybe it's exposed by developers, maybe it's exposed by salespeople. Doesn't matter, but it's exposed. And to control this, the main question during this presentation is not how, but what I should to do with this information. And using this technique that attacker can use in your infrastructure to compromise your assets. As a security engineer, you need to perform same tricks. You need to scan your assets, exposed assets. You need to scan the public repositories of your developers, of your people, of your contributor for sensitive data, for secrets. And you just can perform the open source intelligence. And I think it's not difficult steps, but you need to perform it. Sometimes you need to assess what kind of jewels, what kind of crown of jewels available, and you as a security engineer exposing to the internet. So the second question, most interesting question, is about open source, because I'm sure that most of us, when we asked what do you prefer more, open source solutions or commercial solutions, the answer will be open source, of course, because I don't need to pay the money. So sometimes the open source solutions implemented in big organizations, enterprise level organizations, and not only by people who focused on security. If you're a developer, if you are DevSecOps, you need to develop something, you need to secure this something, and you need to push the something. Yes, so you need to combine few expertise in one brain. So you need to use also classic development dashboards. One of the dashboards that quite popular according to GitHub, for example, is a Flower. I'm not a developer. I just Googled like what the DevSecOps usually, what kind of tools DevSecOps used in the pipeline, and I received some GitHub links. So one of the links, arbitrary links, leads to the Flower, and you see that interface. This interface shows us that the Python scripts that works with the multi-threads mode, they also can be managed by Flower, and this dashboard shows you the state of the management. So during the state of the management, you can extract some sensitive data from the memory that script operates with. And this task management, for example, includes the operations by your scripts, the extracting the sensitive information, debug information, etc. And if you see the exposed asset, you will see that Flower is also quite popular instrument worldwide that exposed to the internet. And if you're a security researcher, you will think that, okay, maybe I need to find some vulnerability there. Maybe I need to compromise it. And you know that dashboard of the Flower, it's pretty simple dashboard. There are not of input fields, but I found only one input field. And for me, it was a Deja Vu because a few months before I looked at my router, I found only one input field. And this input field was affected by cross-site scripting, DOM-based cross-site scripting attack. And when I was dig deeper to the router, I've identified different kind of vulnerabilities, hard-coded credentials, remote code execution, etc., etc. So Deja Vu. That's why, because this one input field was affected by injection, JavaScript injection, and any kind of injections, cross-site scripting. So I decided that maybe I don't need to move forward with the Flower. Maybe I need to move forward with the most interesting security-related stuff. And because I've tried to implement in my workflow, I tried to implement security operation orchestration platform that will automate different kind of scripting, automate different kind of actions, security actions, not only applications security actions, but also infrastructure security. And there were 2 years, not sure that 2 years, but 2 years ago, yeah, it was only one open source solutions on the market. There was a lot of commercial solutions that we call SOAR, Security Operation Orchestration Platform, but in open source, it was only Patrol. And this Patrol was quite popular because it was a unique product in open source. You can just install different kind of engines in Dockers, and these engines can be managed by dashboard, and you can create the scripting scenarios if you are a security engineer. And I decided to replace dashboard of Patrol by my dashboard for my own purposes. And during the implementation, I've identified that containers engine, one of the popular engine with Nmap, can be compromised. So this container received the command from the dashboard without any sanitization. And it means that if someone can direct access to this container, can access it directly, he can inject the string that leads to the remote code execution. And my first question was okay, it was quite obvious. Yes, it's an obvious entry point. Why the author not sanitize the string? And I found in the commentary in developers in the Patrol developer repository that he knows about it problem, and you need to sanitize it not in the container side, but sanitize it on the dashboard side. It means that if your container somehow is exposed, so your product can be compromised and can be entry points to your cluster, to your infrastructure, etc. So this is an example how security product needs to be secured, needs to be hardened. Another example, because we mentioned containers, we mentioned Dockers. Sometimes Dockers that we download from the repository, from the Docker Hub, they need to be assessed also. We need to check what kind of Docker image our developers or we are using in the pipeline. And for example, if your product secured enough, if your IT software as a service platform passed all penetration tests, passed all bug bounty activities, if once you download the wrong Docker container, for example, Docker container with not properly integrated Nginx, you can be compromised because in this case, not correctly configured Nginx Docker image allowed you to inject the arbitrary header, and this header can be reflected somewhere. Yes, and this header, if it's trustful header for your application, it can be reflected in your application page. In this case, you can manipulate by cache, you can manipulate by different scenarios of cache poisoning attacks, etc., etc. So the simple thing, you need to assess all third-party components in your infrastructure. And if you are using the security third-party components, you need to assess it too, because usually security engineers, they are like gods in the infrastructure. Everyone trusts them, and only security guys need to assess themselves to check their products. And this is the example, another example of the penetration testing that was quite funny. We trying to assess penetration. We performed the penetration test for the company that developed the product, IT product, and this company has a Jira. And using the Jira ticketing system for the bugs for the customers, we insert the burp collaborator link. The link is quite simple. If someone visits your link, you will receive the notification that someone was here, someone touched your link. In this case, we identified that we just published the link with the something social engineering kind of a message, like please check my non-working product. This is a message of error. Please check it. We received that someone after a few days, someone touched our link and marked and passed and processed our ticket as a phishing. And it was the security engineers who processed the phishing links. Of course, this engineer can check the link using the virtual machines, but just imagine your daily routine. If you are a security engineer, if you collect the links, what is the probability that you will work with a virtual machine? And I'm sure if we would locate some malicious like payload, this security engineer will be compromised during processing of native ticket. So it's just reminder for us, like for security engineers and for security vendors, what we should to do with this information. First of all, if you are a security vendor, if you are the expert who developed the products for security experts, you need to also follow by SDLC principle. And I'm sure that big companies follow it, but it's just a reminder. And if you're a security vendor, you need to educate your users, because sometimes your users can be not so advanced in terms of using your product. Yes, sometimes you've seen how many security solutions exposed online. You need to periodically scan your product exposed worldwide, and you need to submit information for your potential customers or your real customers that please remove the product from the exposure from the internet. But if you're a security engineer, you need also to perform basic steps. You need also to follow your code of conduct. Do not click on the links. Yes, this actually not only for trivial developer, for HR people or financial people or legal people. It's also actual for security engineers. You need to remind yourself that you also can be compromised. And of course, third-party products, third-party companies that you use in your pipeline, you need to assess it. And you will say that, Denis, how I can assess it because I have a lot of solutions. What I should to do with that? And one of the recommendation is use the open source solution to assess your open source. For example, the CodeQL. CodeQL is the GitHub tool that allows you to follow for your popular repositories or popular components and repositories of these components that you use in your pipeline. And you can use this CodeQL database to follow for security notifications regarding your third-party components. And of course, remember the code of conduct. Even if you're a security guy, sometimes you can be an entry point, because we are security people who train another people, yes, for cyber hygiene. And we need also to follow the rules. And we also need to be a paranoid, because sometimes the red teamers can use you like an entry point. And by the way, we have some story how to use red teamers to compromise the infrastructure, but I think it's another story. So colleagues, thank you for your attention. We'll be waiting for your question.
Thank you very much, Denis. It was great talk. So we're waiting. If you have the questions, please put it on the Q&A panel. Let's wait some seconds. Can't see any questions for now. Anyone? Okay, the presentation will be uploaded on the OWASP Israel site, so it will be available. Okay, we have some questions from the, can you give an example of IC?
Yeah, we need to clarify what is the ISC.
I think it's about the infrastructure as a code.
Infrastructure as a code. You mean some example of compromising? The story is how we can compromise this this kind of technologies of automation.
Yes,
If
like
yes,
CloudFront.
yeah, we are not used. My experience has now any kind of examples how to use infrastructure as a code as an entry point. I think we must use the more trivial things in the infrastructure. But I think it's a good research topic. How this kind of automation can be compromised. Maybe that's a good research. And maybe you can perform this research based on these knowledges. How to compromise these infrastructures and how to protect it additionally, how to organize the hardening. Yeah, give me a 5 because you think it's a good idea also.
Okay, thanks. More questions? So, okay. Thank you very much, Denis. Have a good day. We'll continue on our track prepare for the next session. So see you.
See you. Bye-bye.